Let's get started. Okay, so guys, we're starting on imaginary numbers, and they make up half of complex numbers. So complex numbers are when we combine real numbers with imaginary numbers. And so we're going to contrast imaginary numbers with real numbers. What's a real number? But anything that can be expressed on a number line. Okay, so they're real numbers. And imaginary numbers is basically just a clever tool that we can use to solve things like this. Okay, so if I told you to solve this, you'd go, that doesn't have a solution because you can't find the square root of a negative number. You're correct, you can't, there's no real solution, right? Remember, you do that with your calculator, it says no real solutions, but there are imaginary ones. And so that's what we're going to be looking at today and in the coming lessons. And so its physical significance, I will send an article to you that you can have a read of, but it's more or less just some cool maths that we can do to manipulate and find out some answers. So if we're going to solve this equation, all right, with square root both sides, we have x is plus or minus root 10. Okay, so that's a real solution, isn't it? The square root of 10, what's that going to be? 3.1, something like that. If we have x squared equals minus 10, this is our definition, okay? I is the square root of minus 1. So if we have x squared is minus 10, we're going to get x is plus or minus the square root of minus 10. And one way we could write that using surd operations is it's plus or minus the square root of 10 times the square root of minus 1. Okay, so we know surd operations, root A times root B equals root of AB. And so we can do the opposite. And then we've defined root of minus 1 as I. So our solutions are plus or minus the square root of 10 times I, where I is the imaginary number. Okay, if we have 2x to the 3 plus 10x equals 0, we're told to solve for x. We're going to factorise 2x is common to both. I'm going to pull 2x out the front, and I'm left with in brackets x squared plus 5. Okay, and then we would apply the null factor law. So that is either 2x equals 0 or x squared plus 5 equals 0. This gives us the solution x is 0. And when we process this, we can see we've got a negative number. So normally, or previously, we would have said no real solutions, but we can find the imaginary solution. Plus or minus. Okay, when we get to this one here, we want to solve this equation. So we're going to get rid of that denominator first by multiplying both sides by x squared. So if we go x squared here and x squared here times the whole side, we're going to have x to the 4 plus 3x squared equals 10. Bring the 10 over this side. We'll have x to the 4 plus 3x squared. Take 10 is 0. We're looking for a solution for that. What we can do is cross method here. Okay, if we have x to the 4, we could recognise that's x squared times x squared. Okay, and minus 10, multiples of minus 10 are 10 and 1, or 5 and 2. And so if we go positive 5 and minus 2, right, positive 5 times minus 2 is minus 10. And we can see we'll get 5x squared, and we'll take 2x squared, and when we add those together, we get positive 3x squared. So this is a suitable way that we can factorise it. That x to the 4 plus 3x squared take 10 can be factorised to x squared plus 5 times x squared take 2. Okay, so we're recognising we can factorise that, we can move from there to there. And then we can apply the null factor law to find the solutions. We're going to have x squared plus 5 is 0, up here. X squared plus 5 is 0, or x squared take 2 is 0. And we'll process both of them. Okay, let's move on to the last one. We've got right as a product of linear factors. So on my, I'll keep that one up there, maybe someone's still writing it down. Okay, so before we do this, what you need to remember is difference of two squares. Remember, if we have x squared take a squared, we can write that as x take a times x plus a. So an example might be, if we have x squared take 9, all right, we could write that as x take 3 times x plus 3. Okay, if you were to expand that, you'll get x squared take 9. All right, so we're told write as a product of linear factors, x squared plus 3. So the way we're going to do this is we're going to find what are the roots, and then we're going to put them in linear factors. So the roots occur when it equals 0. So that's going to be x squared is minus 3. And so we'll get x is the square root of 3i, plus or minus. And so then what that means, our solution here is going to, they're the roots, and so if we're going to write it as linear factors, remember we can write it as x take the first linear factor, so root 3i, and x plus the second linear factor, so root 3i. If you are to perform this expansion, all right, and we're not going to be doing that today, but if you were to perform it, then this is what you're going to get, okay? That we've gone the opposite way. We found the roots and we express them as linear factors. If you expand that, then this is what you get. Is there anything else I need to say? No. So let's get into 7e.
Is there an I on the calculator?
No.